In this lecture, we are going to learn about the natural coordinate system. In the previous lecture, we learned about the variation of the shape functions N1 and N2. We also learned about generalized coordinates alpha 1 and alpha 2. So for the same bar element with nodes 1 and 2, let us define natural coordinates. C is the center point at which zeta, which is a natural coordinate, is 0. We need to find out zeta at a point P. The x coordinate of node 1 is x1 and the x coordinate of node 2 is x2. So a natural, or it is also called as intrinsic coordinate system, is denoted by zeta it is a dimensionless set of numbers whose magnitude never exceeds 1. So it is required to find the unknown displacement field at some intermediate point P, which is at a distance x from the origin. Now, using the natural coordinate system, we need to find out zeta, which is distance of PC upon x2 minus x1 upon 2. Okay, so if we see from this point, that is the center point, zeta is 0 and at node 2 zeta is 1. x2 minus x1, this whole term upon 2 is nothing but this distance from C to node 2. Okay, so the length of the bar element 1, 2 is x2 minus x1. If we want half the distance, it will be x2 minus x1 upon 2. Now we need the distance PC. This can be given as, we know that P is at a distance of x from the origin, so x minus x1 plus x2 divided by 2, the whole divided upon x2 minus x1 upon 2. Cross multiplying these terms and replacing x2 minus x1 as L. So first let me cross multiply, so we get 2x, or let me leave this term like this, x minus x1 plus x2 divided by 2 upon L by 2, which is also equal to, this term comes up here, so what I'm doing here is, this term here is x1. I can also write this as 2x1 minus x1, which will again give me x1. So that is exactly what I've got. So here 2 will get cancelled. It will be 2x1 upon 2 plus x2 minus x1 upon 2. So 2 gets cancelled here. So this is minus x1, and x2 minus x1 is nothing but the length. So L upon 2. So you can denote zeta in as this formula given here, or you could just leave it at this. It is the same. Now let's find out what is the shape function in terms of the natural coordinate system. Or zeta. So we have node 1, node 2. Zeta varies from -1 to +1. At the center, we know that zeta equals to 0. The displacement function, again we will take it as alpha 1 plus alpha 2 zeta. If you remember, in the generalized coordinates it was alpha 1 plus alpha 2 x. Now since we are doing in terms of the natural coordinate system, it is zeta. The steps are the same. So at node 1, let the displacement be q1, and we know that zeta equals to -1. So we will have q1 equals to alpha 1 plus alpha 2, and let us call it zeta at 1. At node 2, I'm not yet putting the value of zeta as -1 in this equation. Let us call the displacement at node 2 as q2, and zeta is +1, or let's call it zeta 2. So we have two equations here. q2 equals to alpha 1 plus alpha 2 zeta 2. If I want to write this in the matrix form, it will be in matrix form. The left hand side is a vector of q1 and q2. Then we'll have a 2 by 2 matrix, and the common terms are alpha 1 and alpha 2. So we have 1, zeta 1, 1 and zeta 2. I need to find out what is alpha 1 and alpha 2, for which I will have to find out the inverse of this 2 by 2 matrix. We've discussed about the inverse of the matrix in while doing generalized coordinates. I will not explain that again. So it is determinant of the matrix into transpose of the cofactor. This procedure is the same as we have followed before for generalized coordinates, only here the difference is we don't have any x coordinate, we have only the coordinates in terms of zeta. So now let us substitute for zeta 2 and zeta 1. Zeta 2 was 1 and zeta 1 is -1. So we get 1 upon 2, 1, 1, -1, 1, q1, q2. So now rearranging the very first equation that we had assumed, that is u is equal to alpha 1 plus alpha 2 zeta in matrix form, we will get u equals to 1 zeta into alpha 1 alpha 2. We know what is alpha 1 alpha 2, so let us substitute in this equation for alpha 1 and alpha 2. So it is half into the square matrix q1 q2 vector. Now I need to multiply these two, so I will have 1 minus zeta. So this is a 1 by 2 matrix and this is a 2 by 2 matrix. The resultant matrix should be of the size 1 by 2, that is 1 row and 2 columns, and this is 1 plus zeta multiplied by q1 into q2. I'm taking the half term inside, so it is 1 minus zeta by 2, 1 plus zeta by 2, q1 q2. So these are my shape functions. 1 minus zeta by 2 is the shape function n1 and 1 plus zeta by 2 is the shape function n2. This equation can be rewritten as n1 q1 plus n2 q2, where n1 is 1 minus zeta by 2 and n2 is 1 plus zeta by 2.
Which one?